and we'll try and go to the comparison. Okay, so comparison normally means there are two broad variants under comparison segment. So we are trying to compare either over time. So this obviously means our very famous calculation like year over year or week month over month calculation. They all come under this section. So we are trying to compare certain period of a time with another period in time and see how they are relating with how they are comparing with each other. So that is one part, and the other part is obviously we are trying to compare not across time but across other items. So for example, when we are trying to see a market share, okay, in the mobile segment, you can see Samsung or Apple, so iPhone. So we'll compare across companies, not across time. So these are the broad types of comparisons that can happen. One is over time comparisons, and the other is just among the items, other category comparisons. So we'll take a look at first the overtime comparisons, and under the overtime comparisons we have two other sections as well. So let me just zoom in if I can. Yeah, so we have something on the rightmost side. We have few periods, and few periods in the sense that when we are trying to compare across few time periods. Okay, and under the few time periods we have many categories. We are under the few periods we are trying to compare across a few categories or many categories. Let's just quickly go to Tableau and see what these mean as well. Yeah, let me open a new sheet. Okay, now let me connect to samples first of all. Okay, first we are trying to compare over time. So obviously I'll bring in my time related, date related field. So order date onto my x-axis, and what level I have to choose. So for the time being, let me go with year, and I'll explain why we are going with year in this example in a minute. So I have my 2017, 2018, and 2019 four data points. So basically I have four data points, and let me just look at sales. So yep, I have sales as a line, and if I go back here to our chart, I can see, okay, over time I got my time period, few periods. So I have less than 4 or 5 data points, which are just basically I have, since I have at the years, I'm just looking at 4 data points. So few periods that satisfies, and many categories. Okay, so obviously it's simple to comprehend. So I'll just tag maybe subcategory field into color. So that will give me let me just entire view. Yeah, so that will give me for each of the subcategory a single line across all these 4 years, and saying that how the sales have been going across. So normally whenever you have subcategories, whenever you trying to get the categories in this sort of a view, it is not recommended that if the categories are more than 10, you should go with it. 10, 12, 13, it's manageable, but it's still not so viewer friendly and easy to read. So at max some less than 10 is recommended, but since in this category we have 12 categories, we just went with it. So yeah, so normally but less than 10 is what is recommended. So this is what it means for our first type of comparison chart, the rightmost one, few periods but many categories. And then we have few periods but single or few categories. Obviously when the categories are less than 4 or 5, it corresponds to the same. So instead of let me just duplicate this at the same level, on the same year level, I'm trying to just remove subcategory and pull category in. So I have just 3 categories. So showing lines at this point is not so viewer friendly again. So whenever we have more than 5 or 6 categories, it's recommended to go with lines. But when we have less than 5 categories, it's optimal for us to go with the option called it's what do we call this? It's a type of bar chart, clustered bar chart. Yeah, clustered bar chart. So I just have to now just have to arrange it in a way of thereby. Yeah. So in 2017, what are the sales? Let me color it accordingly with the right category. So yeah, so few categories, few periods. So this sort of chart would be most appropriate to compare. So in 2017, I can compare across categories. I can also compare each category across years as well. And a similar chart will not work in this case. It will just be too much clustering, and no one will be able to make sense of what's happening. So that's on the over time few periods charts, and we have over time many periods. So let's just see what those are, and go to Tableau. Just imagine the same chart. Okay, let me duplicate this. It's actually similar to this. Let me it's actually something that which we already talked about, that whenever we have, let's say, order ID, let me just go with years. Okay, and my sales as a bar. Whenever we have more data points on the x-axis to show, let me just go back to again previous example to go at day level. It's not recommended to show in a bar format. It's mostly it's recommended to show a line format. Okay, so that's what it means. And also let me just show a couple of quick other examples as well. Sales, not necessarily we have to go at a discrete level. We can go at maybe month level. Yeah, so this is also possible. So one other important point to note here is we are talking about over time many periods, but non-cyclical data. Okay, there is a some term called cyclical data, non-cyclical data. What that means essentially in a very brief terms is your data's following any patterns across the time period. So for example, there could be a chance that your data always follows a certain general trend over different time periods across the year. Same pattern is followed from January to December. Again, from next year January to next year December, you will follow a similar trend. So if you observe this trend line that we see here, you can see there is a slight pattern repetition across years. So this is January 2017, and this is September, October, and December 2017. So there's a, if you can see, there's a typical W kind of trend across the year, and we can see the same W kind of trend in all the years. Here also there's a W, here also there's a W in 2019, here also there's a W in 2020. So there's some amount of cyclicity that is happening across years in this particular visualizations. So normally what this chart is referring is whenever you have non-cyclical data, it's recommended to go with this approach. But let's see what that also means. Let's just go with one more example here. Let's connect to world indicators data and just get the year column. Okay, here actually there is only year level information that is given. There's month or day, it's not given. So let's just go with it for the time being, and let's just see maybe our CO2 emissions and energy usage. Yeah, so we can see here we are not observing any trends across. across the periods. So maybe I'm not sure if we can have the ability to drill down to months, we might be able to see some trends, but normally this sort of data where CO2 or energy uses doesn't follow generally any trends, any cyclicity related trends. They normally tend to go in a either increasing trend or decreasing trend overall, without any following any certain cyclicity pattern. So in this sort of scenario, when data is not following any cyclicity pattern, it's recommended this way. So let's quickly jump to our other last part for the today's session, which is cyclical data. So we have many periods, but we want to look at cyclical data. Let's understand first of all what cyclical data is and where it is normally used. So there's one very good article that I found which explains the need for a different visualization other than a line chart for a cyclical data. Okay, let me quickly walk you through it. So what this author of this article is trying to explain here is he has some 3 charts. Okay, in these 3 charts he is trying to convey a importance of a need for new type of visualization for cyclical data. So for example, the first chart we see here, so I don't know how much you can see it, but what it's trying to show you here is percentage of the population shopping throughout the day in Norway. So we have on the x-axis we have time, okay, from starting from midnight 1 o'clock a.m. to 11 p.m. On that day, and we are just trying to see how much percentage of the population is shopping at what time. And obviously we can see that shopping normally starts at 9 a.m. and goes on till maybe 11 p.m. So there's a nice little trend. So that's well and good. Now let's look at another point, another graph which shows percentage of the population sleeping throughout the day. And now at the x-axis is fixed at the same time scale, starting from midnight 1 o'clock a.m. to 12 p.m. Midnight to midnight. So, and we can see that almost during the early morning hours, almost everyone is asleep, and around like 5 o'clock or 6 o'clock people start to wake up. During the day, very less people sleeping, and again people start to sleep after 9 p.m. It goes up until back to 100%. Now, very interesting point that we need to observe from these 2 charts is if we see the x-axis for all these 2 charts are static. I mean, they are fixed on a same time scale, from starting from midnight to ending to midnight. But if you are trying to understand this visualization, this axis is good and most appropriate for you, because it is giving you all the information related to shopping throughout the day in the time scale that you have fixed nicely. When I mean by nicely, so it's basically in one continuous line that you are able to see. But whereas the same time scale, when we are trying to observe the sleeping pattern, it's discontinuing in between. Okay, so for example, people who are trying to observe sleeping patterns, this axis is not set right for them. So ideally for those people who are trying to observe this graph, the axis should have been instead of from midnight to midnight, it should be more likely where the sleeping activity is higher. So basically it should be from 9 p.m. where the sleeping people tend to go to sleep, to go to bed, and then it should be from here till 11 a.m. So this should have been the axis, so they can see one single continuous line in the graph, just like here, without any discontinuity in the the graph line. So this is what the author is saying, that so normally the x-axis for any sort of this cyclical data. Okay, why is this a cyclical data? Because this repetition, this behavior of customer shopping or people normally going to bed will repeat on a day-to-day basis. It will normally follow the same trend, same pattern, and there could be many other observations as well. If you can see here, this is another chart which gives us, okay, the gray area is showing basically the percentage of people sleeping. It decreases, and in that area during the daytime, what are the other activities that normally people do in terms of percentage. So if you see the axis here, okay, it is now changed from the earlier axis. Earlier it was midnight to midnight. Here it is now more likely from 4 a.m. to 4 a.m. So we can see the sleeping trend and a one single continuous line rather than it breaking, starting abruptly from the beginning, at the beginning of the chart, and breaking in between at the end of the chart. So for people like who are interested in understanding this sort of trying to see these sort of activities or sleeping trends, the x-axis will be more suitable to have from 4 a.m. to 4 p.m. Now
that is to say, it's more symmetrical this way, right?
Yeah, it's basically more viewer friendly and conveys more information on when people are observing sleeping trends. So, but this would be the wrong axis to show if they are trying to understand this one, shopping activity, because again now if you show 4 a.m. to 4 p.m. This line will take a break. So it will basically 4 a.m. to you understood, right? So normally what the author is trying to say is, whatever the information that you're trying to say, convey it in a single, make sure that it happens in a single line in a graph. It shouldn't break like this continuity. So and because of that, so they have for whatever the cyclical data, there is a in order to we don't know what axis is better for what type of analysis. So we are able to get the apprehension that 4 a.m. to 4 a.m. is good for sleeping pattern, because we know that most people stay asleep in that period, something like that. That will be covered in that time scale properly without any discontinuity. But if they are looking at something else, we can't comprehend every possible analysis, and we can't change the time scale accordingly. So for that reason, there is a introduction to circular charts, okay, for normally cyclical data. So where no matter what time scale that you choose, so the entire point of discontinuity is avoided. So we just represent that in a circular format, and the trend just continues from wherever it is left off for the cyclical data. And there are different variants to it. You can follow either a 12-hour pattern, circular plot, plot, or 24-hour plot. And there are different variants to it, but we will not go there. So yeah, the idea behind so whenever you're trying to look at cyclical data, it's normally important to go for a cyclical plot if required, but rather than just the line plot. Okay, I think we'll stop it here, and we'll continue from our next session.
Yeah, we'll continue next session. Okay, great, awesome.